The name of this lesson is Evaluate Double Angles and Half Angles. The key word here is evaluate. When we evaluate something, we typically have a number as an answer, as opposed to the last lesson we did where we figured just simplify to an expression. So key word here is we are going to have typically a number as an answer. As a refresher, here is our double angle formulas. We've spent plenty of time going through these, so I am not going to repeat these or anything, but this is just a review of what we've already learned. Here are our half angle formulas. And remember, there's one for sine, one for cosine, and two for tangent. Again, this is just reviewing what we've already learned for the double and half angle formulas. If you haven't watched the lesson on simplifying using double and half angle formulas, go ahead and do that first. And it does come first in the playlist. Okay, so here's what we're really getting to. Note that in this lesson, you are not solving for theta. Okay, I am going to definitely underline that in red. You are not solving for theta. Okay, here's what you're doing. You are solving for a trig ratio of either theta over 2 or 2 theta. Now notice, the theta over 2 represents the double angle, and the 2 theta represents the half angle. So something a question might ask is, what is sine of 2 theta? Okay, that's one way. And you're going to get an answer back. You're going to get a ratio back. For example, you might get 3 over 4 back or something. I don't know. It might ask, what's tangent of theta over 2? Okay, again, you're going to get a number back, say 4 over 7 or something. Okay, another way it might ask is, what is cosine of theta over 2? And again, you're going to get a number answer back, and that's why the name of this lesson is Evaluate. You're trying to figure out and you're trying to come up with a number. You're not just simplifying to an expression. So without further ado, let's look at the first example. Okay, so let's read this together. It says, if cosine of theta is equal to 3/5, then what is sine of 2 theta? So kind of the structure of this, let me make this a little bit bigger so you can see. The structure of this is that they're going to give you a trig function, okay, and it's usually going to be a regular trig function, like with a regular angle in it. So in this case, it's just a single theta. So they're saying that cosine of theta is equal to 3/5, right? So what do we know off the bat? Well, off the bat, we can say, what's the definition of cosine? It's adjacent over hypotenuse. We know the adjacent side is 3, and we know the hypotenuse is 5, right? Based off this information that cosine of theta is equal to 3/5. The question is asking, what is sine of 2 theta? Okay, so this is at the heart of what this lesson is about, and a lot of times it's hard to title a lesson. To me, this is the shortest and most concise way to title it. We're evaluating double and half angles, and if you wanted to go further, given another trig function. So in this case, we're given that cosine of theta is equal to 3/5. So again, what we're really trying to figure out is, what is sine of 2 theta? And these questions can be hard if you don't follow the steps that I teach you. And I say that to my students all the time. Just follow the steps and you'll be fine. So we're going to follow the steps on this, and we're going to figure out what is sine of twice the angle theta if cosine of the original angle is equal to 3/5. Alright, so the first step to success here, step 1, is going to be to write out an identity. And since it's sine of 2 theta, there's really only one identity that's going to make sense for this, and that sine of 2 theta is equal to 2 sine theta cosine theta. Now, you might be thinking, what about the other ones when there's 2 options? Well, we'll get to that later. But if you go back to the double angle formulas, there's only one for sine of 2 theta. As I've said before, it's basically the most, you need to know this one more than any other identity. Sine of 2 theta equals 2 sine theta cosine theta. And remember, my advice was, if you say it enough, you're going to remember it. So write out the identity that's applicable, and again, it goes back to the fact that they're asking for what is sine of 2 theta. So naturally, you need to know that identity, right? I'll give you a hint. We already know what cosine of theta is, right? So we can just plug that right in. We need to now figure out sine of theta, which is what we're about to do. And then once we know both of those, we can figure out sine of 2 theta. So step 2 is to solve for an unknown trig function. So in this particular case, the unknown trig function is sine of 2 theta. Sine of theta. We already know what cosine of theta is, again, because it gave us to us here. We just don't know what sine of theta is. If we know both of those, we can plug them into the formula, multiply by 2, and that will give us sine of 2 theta, which is what the question is asking. So let's read this together. It says we will do this by using what is given to us, drawing a triangle and solving for the third side. So that's typically what you're going to do with these problems, is just draw a triangle, because after all, trigonometry is nothing more than visual triangles, which is why I love it so much. I love trigonometry so much because it involves analytics, which I really like, kind of like algebra type questions, and it also involves visuals, and just both of those together I think really going to help solidify these concepts. So as I said before, we said that cosine of theta is equal to 3/5. So right off the bat, that tells us that the adjacent side is 3. So when we go to draw this triangle, we're going to label the adjacent side as 3 of our angle theta. So just draw any triangle, it doesn't matter how you orient it, but since my theta is here, I'm going to say, okay, my adjacent side must be 3, and then it says the hypotenuse is going to be 5. So when I go to label that on the triangle, I'm going to label that side as 5. And then what I don't know is my opposite side, right? But that leads us to this right here. This is the common Pythagorean triplet, 3, 4, 5 triangle. The most famous right triangle as far as Pythagorean triplets go. Therefore, I know then that the opposite side is going to be 4. So I can basically rewrite this triangle or redraw it, and I don't have to redraw it. I can just label the opposite side as 4. And now that I know the opposite side is 4, I'll use green, I know that sine, it must be 4/5, since sine is opposite over hypotenuse. I already knew that the hypotenuse was 5 from the cosine information. So basically drawing it out, you don't have to necessarily if you're a wizard, but for me I like to draw it. Then I can see, okay, sine of theta is equal to 4/5, and that's what I needed to know. Again, we're basically part of step 2 is figuring out that other part of the formula so that we can plug both of these in to figure out sine of 2 theta. So now I know that sine is equal to 4/5. Now we can fill the rest of the double angle formula. Fill in, rather. So that's what we're going to do for step 3. We're going to plug in known values. So we know sine of theta is equal to 2 sine theta cosine theta. That's what we wrote for step 1. Now we're going to plug in 4/5 for sine and 3/5 for cosine. 3/5 is what was given. 4/5 is what we just figured out. And step 4 is to solve. And that's pretty easy. Basically, 2 times 4 is 8, times 3 is 24. That's on the top. On the bottom, we have 5 times 5 is 25. And guess what, folks? That's the answer. Sine of 2 theta is equal to 24 over 25, given that cosine of theta is equal to 3/5. Now, this is kind of an abstract problem. We never were given theta, right? We never knew what it was. And as I've said before, I'm going to go back to this slide right here. We are not solving for theta. We're solving for a trig ratio of either the half angle or the double angle. So I want to make this a little bit more concrete for you before we finish out this lesson. Let's just say that the angle was 30 degrees. All right, I have no idea if it was. Let's say that this angle right here was 30. So if it was 30 and the cosine was 3/5, what we're saying with our answer is, what would the sine be if the angle was doubled to 60? And the answer, if, for example, it was 30, if we double it to 60, then the sine would now be 24 over 25. Now look how close this is to 1. This is extremely close, hinting at the fact that if we were to double the triangle, the new triangle would look like this, to where the opposite side would be very close to the hypotenuse, namely opposite being 24, hypotenuse being 25. So that kind of gives you an idea of what happens if you were to double that angle. It's also going to get a lot bigger, and it's going to be closer to 90 and form a ratio such as this. That's it for this particular example of evaluating a double or half angle given a trig ratio. If you have any other questions about this, let me know.